Imagine you want to read 3 books at the same time and make a good summary about them. It's nearly impossible for a human to put all those 3 books at the table, read and interpret all the information showing them at the same time. Doing tasks like this at the same time in software programming is called parallelism. To parallelize your book summaries, you would call 3 friends and give a book to each other. Then, as each individual friend finishes not only reading but also summarizing the whole thing for you, they would reach you out with the final content and you'd save all this file into a single notebook and finish the job. By splitting the problem, you save time and make the process at least 3 times faster and haven't overloaded anybody with too many tasks at the same time. The child process module in Node.js helps us to do exactly the same thing. For the project I prepared for you, your task is to read 3 million items from a bunch of files that contains user data and output them into a single file. The output file should contain only the users that have their mail hosted on gmail.com. So you have 3 different files containing users' data with at least 1 million items each. For each file, you are going to spin up a child process where individual child processes will read the file, filtering only the users that have their email as gmail.com. After filtering the data, the child process will reply back with the user item, so the main process will save the information on an output file. This is amazing because splitting the data through different processes would use more processing power from your machine to make the task run faster. Let's check this out in practice then. All right, we are in the 5th module. That's amazing, isn't it? Let's create it. And the first folder here is gonna be child process. Okay, so here I'm on Node.js 19. I'm gonna go on the module 5 in the first one. Okay, let's initialize a Node.js project as we've been doing a lot. Let's set the type module. And then let's create our source folder so we can put all the files there. Okay, and then for this task, we're gonna produce a lot of data. So I like using the faker.js module to create all the data for us. So let's install it first. So it's gonna be at faker.js, faker, and the version is gonna be 7.6. Perfect. Let's create a file here called seed, which we're gonna use to produce our files, right? We're gonna start small, but then it's gonna be millions and millions of items. Okay, so let's import first the faker. So from faker, it's gonna have a faker, okay? And we're gonna create a function to create a random user, okay? This is code snippet I just got from their own website. So we're gonna have the user ID. It's gonna be faker, data type, UID, then a username, faker, internet, username, email, faker, internet, email, phone, faker, phone number, and then let's put some configuration properties here, like registered at faker, date, past, just to generate some data for us. Let's check if this one is working. So let's create a random user. I'm gonna create here a seed, which will have node, watch, source, seed, JS. So npm run seed, and let's check this out if they created our file. It seems it's okay. So every time we save here, we're gonna see different values, right? So faker helps us a lot to generate data. Nice. With it, I'm gonna create two different files. So I'm gonna create the database folder, and then let's say we're gonna import from node.fs the create write string. Okay, and let's create here our file 1, because we're gonna have 3 different files to make things interesting. We're gonna save this on our database, and let's say file 1 and the JSON, right? Now I'm gonna just duplicate this one and change the name. So file 2 and now file 3. Okay, this way we're gonna create 3 different files, and then we can fill them with data. Nice. So let's put them all on our array. So file 2, file 3 for each, and then I'm gonna grab the file and the index. Okay, so I'm gonna grab here the name. So current file, it's gonna be file index. Okay, but the index always starts from 0, so I'm gonna put just +1. I'm gonna put a console time here so we can measure the timestamp. So it's gonna call the current file, so we can check how long it took to process this one. And then let's create a for. So I equals 0, I 1 4 zeros just to get started, and I ++. And then we can use file write to save our data. So I'm gonna call JSON string file, create random user, and I'm gonna put a break line here because it's gonna be a end JSON file. Nice. After it, we're gonna use the file.end so we can close the file securely, and then I think this might help. Just remember to put some comma here. Okay. Nice. File 1, file 2, and file 3 seems to be already processed. We can go there and see a lot of files, right? So right now we have 1,000 items on each one because it's 1 and 4 zeros, right? Nice. But later we're gonna put this as 1,000,000 items. It's gonna be crazy nice. Okay, we have our files. So for the seed one, it's okay. I'm gonna create a start here. So we're gonna have exactly the same thing here, but it's gonna be the index, and then we create the index here. Okay, nice, perfect. Well, remember I said when we are running a child process, we have a main process which is gonna spin up background tasks. So I'm gonna create right away a background job.js just to keep this way working here. Okay, nice. I'm gonna put like a console log initializing, and every process have a PID so we can log it out, and I can put like process.on message console.log message and message to string just in case. Okay, just it for now. All right, the goal is we're gonna have 3 different files, right? But I don't want to read the first file and then the second and then the third. I want to run them in parallel. So I'm gonna merge them into a single string, and then we can execute them in parallel so we can receive data from where else we have. Okay, so this is gonna be very interesting, and this is kind of thing that is rare to find out there. To get started, let's grab from node.fs promises the red deer. Okay, we can copy from the seed, we can copy the time and time end. So I'm gonna paste here. It's gonna be called child processes. Okay, so we can measure the time we start and time it ended. Nice. So I'm gonna grab the files there. So I'm gonna have red deer, and it's gonna be on the database. Okay, Remember, when I'm executing from the package JSON, when I'm using just a slash, it's because it's gonna be here, not from the source, right? But if I run node from the source folder, I should have either go back or actually put the full path here. So just to save time, I'm gonna put the folder right away. Nice. Well, but my goal is to create a background file. So I'm gonna create here from node fs the right string, and I'm gonna call output. So it's gonna be creator string, it's gonna be on the database, and I will say output gmail.ndjson, right? So I'm gonna have here just in a variable output file name, and then here output file name. Okay, so once we have the files, we will have what we need to process there, right? So I'm gonna stop and run npm start. So we have file 1, file 2, and file 3. But as we've been processing this file later, I think we're gonna have a problem with this output, right? So I'm gonna ignore this output, so we won't process it. So I will have here filter item that doesn't includes the output. Okay, nice. Just run there. So if I create here any, yeah, actually we have here, right, the file, but the output is not appearing here, so it's fine, it's nice. So if I remove the filter, you can see the output, but if I comment it, it's working fine. Nice. Well, my goal is to send each individual file to a new background job, okay? So let's import the child process module from node, child process, the fork. The fork we use to invoke JavaScript programs. We have spawn that we usually use to invoke any other binaries or programming languages from Node.js. All right, so I'm gonna use fork. We can actually navigate on the files. So for const file of files, just to make sure everything is working fine, okay? So I'm gonna say it's the back, so it's gonna be our background file. I will actually move this one here because I won't use later, and I will have here the background job path. It's gonna be our background job, okay? So remember, always the source because we are running from the root. Nice. So the fork is gonna receive which file, it's gonna receive the data. We will have the parameters, and then I'm gonna pass silent false to receive all the console.logs that we have there. So this will print out the consoles we have in the background job. Perfect. Well, with it, I'm gonna call it CP for child process, right? And then I will say what we have here. We have just a message, so we can send a message, okay, to each individual project, and I'm gonna send the file as well, right? Nice. Let's see if it works. So now we receive initializing 3 times because we have 3 different projects, right? And then we have the files going there. Ooh, it's turning to something, right? Well, we should just, because we are gonna read all these files as streams on the background file. So we should pass all the path. So it's gonna be file. Let's see if it works now. Yeah, we have database, file, and then it's gonna be working. Hopefully, right? Nice. Well, in the other side, we can actually say, well, let's change just something here. If I run this program just with Node, you're gonna see that the whole thing is blocked, right? because a child process is a program that can receive a lot of messages. So I'm gonna grab just the first message. This background job, it's gonna execute and then queue the process. So if I run this, you're gonna see that our terminal, it's okay, okay? So once just to get the first message and then die. Perfect, my friend. Let's make something here. What if we use like we import from node string the create read, oops, it's from fs, right? Fs create read string, and we had node string promises pipeline. So we can have the pipeline here, the create read string on the message, and then we have something as a async generator function. So const chunk of source, and then console.log chunk and chunk. Let's see what happens now. So I'm gonna run npm start again. We can see a lot of buffers, right? If I put to string and save it again, I actually have to save the index, and then all the data is there, right? Just notice a thing. In the previous modules, we were avoiding using directly the async generator. We usually use the readable from, the writable from. This is actually was a bug in the Node.js core that I solved, so you can see in the issue I'm gonna put here in the video description. But we don't need this anymore. We don't need to readable from or writable from, transform from. You can use directly a async generator, okay? However, if we see here the chunk, let me put something here so we can annotate. You can see that we don't have like for each ng-json separate chunk, right? We want to process this individually. So we're gonna install a package called split, okay? So the split is gonna help us to break those lines into JSON files, right? So by default, the split is gonna try finding the break lines. So if we run now, npm start split, I have to import it. Let's move this one for here, and then import split from split. Save here and save the index, and now we can see each individual chunk right there. Ooh, very nice, isn't it? Well, we can see the premature close here because the program was closed before finishing reading the whole file. We're gonna fix this later, but for now, this is what we want, okay? Nice. I'm gonna just comment this line and actually comment the whole pipeline here so we can work on our Node.js project, right? On the main process first. So I'm gonna put the message, save, and let's just make this happen right now, and then we fix the background job. Now, what I'm gonna do, I want to make every responses from the background jobs we had in a single readable string. Imagine I have a lot of data sources, and I want to put all of them on a single funnel and actually act with a transform, a writable, and whatever I want, okay? So how do we do this? This is pretty interesting, isn't it? First of all, we should convert our child process to a string. So child process as string. So I'm gonna have the child process and the file so we can convert this better, okay? Well, we can actually send messages back. Let's just send like process.send, okay, hello. Just to check if we can receive the messages back, okay? So right now we can create an array first, child processes, okay? And then I'm gonna call the child process as a string, I'm gonna send the child process, and the send I'm gonna send from this function. Okay, nice. So we have the child process and the file for each file we have. Perfect. This is gonna be our stream and the child processes dot push, so we can merge them all into a single stream. And now the child process is very likely any other Node.js events. So we're gonna import now the readable stream readable, and then we're gonna create our readable string first. So it's gonna be readable, read, and just the signature for now. Okay, so once we have a message from the child process, we can get this message and plot it to the string. So string push message. Okay, and then the send here is gonna send the file. So for each one we have, I'm gonna wait for the message here, and I will produce data to this readable string. Well, now all the child processes we have are Node.js streams. Okay, we are putting them all into an array, and then now we can actually try merging them into a single Node.js project. But just a matter of curiosity, let's grab the first one, child processes 0. We know they are Node.js streams, so now we can import from promises the pipeline, and I'm gonna wait the pipeline here, and I'm gonna have, I can actually copy paste from here, right? So we save time. Nice. So the first one is gonna be our readable stream. We are just acting in the first one, so we're gonna wait for messages from the first. So what we could do here, just to know which one we are talking about, is to use JSON string file message. We pass the message itself, and we can say like the PID. So we can grab the PID, and we can go further and pass the file message. I will just split whatever we have here. Perfect. Now we're gonna have more data coming to our pipeline. So I just saved, cannot write to a pipe. Why not? Processes, push stream. Oh, it's missing the return here, right? Return string. Ooh, so here we received a bunch of things from the watch mode that I don't know why. This might be a bug. So we can run directly the node src on our index. Oh, see, we have the okay hello from the file and the JSON, and from the process 5,000. Ooh, exciting, isn't it? So it's almost working. So the streams part, it's okay. Now we should create the merging part. So function merge, and we're gonna receive a bunch of streams. Now we're gonna do something very hacky. We're gonna use a pass-through string to concat all the data. Okay, so I'm gonna use pass-through. It's very crazy. I'm gonna use let pass with the pass-through, and then I'm gonna iterate through each string we have of streams, and then my old pass is gonna receive the new one piped with the previous, and I'll put end false because I don't want them to end. I'm gonna end it manually. Okay, so once this string ended, I can actually put here a control variable waiting. So we're gonna have streams length. So I'm gonna say that it will only stop when all the streams finish reading. So we can actually decrease this value. So if it reaches 0, then we can use the pass, emit, end. Okay? So every time we have an end, we're gonna check if the waiting here is 0, and if it's 0, we're gonna send the end, and then all the streams will be ended. Okay, let's check this out. Let's see if it works. Don't forget to return the pass, and then right here, let's merge them all streams. It's the merge of what? Our child processes. I will rename process streams. I think it's better. And now we can have all of them as a single one. Ooh. So now if I run this code, we can see that we got a message from the file 1, from the file 3, and the file 2 from different processes IDs. Ooh, this is amazing, isn't it? Because we are grabbing a lot of data from different data sources and just putting them all on our funnel so we can process all this data. This is very interesting, my friend. Very interesting. Perfect. We are almost there. I want here to make some control variables. So just to remember what I said about the Node.js back pressure. So I'm gonna concat a break line at the end just to make sure every chunk we receive, it's never gonna be concatenated with another one that we cannot parse to JSON. So using the break line here, we can split on our transform function here and grab whenever we want. So now what I want to do here, I'm gonna use for const line of the chunk to a string. I'm gonna remove all the spaces with trim, and I'm gonna split by the break line we just added there. Okay, just to make sure Node.js won't have any pending queue or pending messages, and it's gonna break for us. Okay, well, I'm gonna grab the file and I'm gonna put the remaining functions, the remaining values on the file. So here we use the parse line. We can have here a console.log that says file is working. Nice. After it, I can actually use the yield JSON string file again on our data. I'm gonna use concat with a break line so we can pass all these remaining values to our output. I think rename with output, right? To output them on our ND.json file. So if we save it and run it again, we can go on our database and check with the file. So we can see the JSON, it's receiving the data as we want, and we can see the PIDs there. Perfect. Well, I want to do something more interesting here. I want to calculate how many items were processed so we can check them all later. Before the child processes, I'm gonna say counters, and then I'm gonna put after our file here the counters on the PID, because every time we use the fork, it generates the PID right away. And I'm gonna say it's gonna receive a counter with 1. Okay, just to say it's gonna start as processing 1. Okay, what else? Well, right after our JSON parse, I'm gonna grab this counter, and then I'm gonna say the counters in the position of the data PID is gonna increase our counter. So in the next line, we can say that our file found counter so far. So let's check this out if it's gonna work. So our file 1 just processed 1 item, the file 2 just 1, and so on. If we go here and put like more cents, we can see that they are receiving a lot of data. If we go to our output file, we have 12 items. Nice, because it's 4 messages multiplied by 3 processes, right? 3 files. Perfect. Now we have our output. We are saving to the output file. Now we should work on our background job file. Nice. So on the background file, I'm gonna remove the other as well. Okay. And I'm gonna do a try cat here. And once we have an error, so just a thing here, if we don't catch the errors on the child process, the whole project or the whole child process is gonna break, right? So we should handle the errors and communicate and send a message to the main process. So I'm gonna create a new pattern here with the status error and then message, and I'm gonna send error. So whenever we want to send messages, I'm gonna send with this pattern. So on the index, on the message here, I'm gonna grab this data. So it's the status and message, right? So if status is equal to error, I'm gonna just print out this result. So message got an error, the PID and the file as we've done here, just to log results, and then the message, and I'm gonna grab the message here, split it by -n. So it's gonna be always a string in this case. Whenever we have an error, I want to stop the process. So to stop, we use new, as you saw in the first class. If you don't want to stop the process with it, the whole processing, you just can omit this line, okay? So this will make our string for this file stop. Okay. Well, we can run right away. We don't have any problems yet, but as long as we have any problem here, we're gonna see it there. Nice. So I'm gonna go back with the pipeline function we have here, and I'm gonna send there. Okay, so I'm reading the file with the read string and the string, splitting by the break lines, and then processing the whole thing. So our goal here is to filter everyone who has the Gmail as the domain on the email. Okay, so if you look up at the file, we can see the last file, the last line is usually empty, right? All of them has one empty. So the first thing here, I'm gonna ignore the empty lines. So length, continue. So ignore empty lines. Nice. So if it's not empty, we can just try parsing the whole thing into JSON and then make our calculation. So Ethan email, because it's a JSON, includes Gmail. I'm gonna continue, right? Because it's Hotmail or Global or any other domain. But if it's Gmail, I will actually send a message to the parent, right? So with the same thing, status, success, and the message, it's gonna be our item. And see, here I'm sending the JSON. I don't need to send a string right away, right? So we can send just the message and parse on the other side. I think this code will already make the magic happen. Let's see. Let's see if it works. So I'm gonna run again. We can see the IPC channel was closed because message is not defined. So I did something wrong here. It's actually message, right? Let's check this out. Whoa, it ran, right? Fast, really fast. But we got some errors here on the split. So we got an error, but we don't know yet what is this error, right? Yeah, because in the error, we should send the error.message. Ooh. It seems we have 3,000 items so far in both items. How do we check that? Well, let's create a bash script to actually check results, right? Check results. So if you are on Linux or on Mac, you will be able to run this one, or you can actually use the Git shell or the Windows Linux subsystem there, right? It's WSL, something like this, right? Well, in Bash, we can use cat and go on a file and use grep to filter, right? So you can filter everyone that has Gmail, and actually can use WC to check the lines. So on the first file, we have 3,000 Gmails. On the second one, also 3,000. And the file 3, also this. But see that we have a space here, right? So in Bash, we can get this result and use BC to convert it to an integer. Okay? So I'm gonna copy this whole thing and say the file 1 is gonna have the whole thing here, but just name it as file 1 here. File, actually, let's just replicate and change the name. File 3. Nice. This way we have all the files. We can create a variable with the total, and then we can use echo to print a sentence here. So it's gonna be file 1 plus file 2 plus file 3. And then I'm gonna get all this thing to the BC. So if you go to BC here and type like 10 plus 10 plus 20, you can see results, right? We are just using the REPL on the Bash to make calculations. Nice. So I have to type exit or quit. Perfect. Now let's just echo the total to see how many items we have. So sh, check results, we have 1,032. Nice. So if we can create an if the total is equal to the current, so let's grab what we have here. So it's gonna be the same thing, but the current will be our final JSON item here, right? So it's gonna be the output Gmail. Okay? So if it's equal to the current values, and then this way I don't need the Gmail, right? Because I want to check all the lines. All the lines should be the values containing the Gmail from the other ones. Okay. So if it's equal, then I'm gonna echo, all right, found current items. So everything's okay. Well, else echo, oh no, the numbers don't match. Current expected total. So this is very useful for us. And just put phi to end the sentence. So if we run again, we can see that, well, there's something wrong. I think a space here. Yeah, a space. Ooh, all right. So it seems all the files okay. So what we could do here, we could say that we want to remove the file first. So I'm gonna copy here, remove, use rm force. So if the file doesn't exit, it won't throw any error. So it's from database output, and then I'm gonna use ee and again, and then we're gonna use the check check results, exactly how we've done on the terminal, right? So first we're gonna remove the file, run our program. So to run our program, we can run without the watch and then check results. So I'm gonna save it and let's run npm start. So it's reprocessing and it seems all right. If you don't trust on the sh, you can go on each file and find Gmail. So it's like we can put here node is 3327 plus. Let's check the second. Gmail 3360 and Gmail 3345. It's exactly the same value the bash is showing us. So we process them all. Well, I want to make a last thing here, which is to process 1,000,000 items per file as we promised, right? So I'm gonna comment this line and I'm gonna put 6 zeros. So 1, 6 zeros, it's 1,000,000 items. Ooh. How long it's gonna take to process 3,000,000 items, right? Because it's 3 different files, and then find out which emails are there, parallelizing all the processes. Ooh. This is very interesting for me, my friend. Well, let's check this out. First, npm run seed. So it's gonna create all new files with 1,000,000 items each. So 8 seconds for the file 1. Probably we're gonna have something similar for the file 2. Yes. And for the file 3, 8 seconds as well. So if we run just the check results, we're gonna see that the numbers don't change because the expected is 998,000 items, just almost 1,000,000 items, right? That's amazing. So let's try running our project. npm start. So I'm gonna run everything and see the whole thing is working right away. We can see the logs there, and if we have any error we can see on the logs as well. And let's wait. Nice, isn't it? We found it. All right, 900 items in just 20. It's incredible, isn't it? 28 seconds to process almost 1,000,000 items. So if we go to our file 1, I don't know if it's gonna break my Visual Studio Code, but it's 1,000,000 items. We can go and find there the Gmail. Yeah, it's too much to Visual Studio Code, but we can go here and check how many lines we generated, right? So very nice, my friend. Almost 1,000,000 items from 3,000,000 items in total. So notice that here we can actually try just a small thing here for error handling. This is very important, and myself, I haven't found any explanation of how to handle errors here. This is why I created this pattern for you. So let's create a counter. Okay, so if our counter reads like 20, okay, I will throw an error, new error, and say found some problem in item. I'll put this in the same line, and then our chunk choose string. Okay, well, because of this line we're gonna go to the catch, right? And our process is gonna send the message back to the index, and it won't break the whole thing. So let's try out. So I'm gonna run it and start again. And now check this out. We have an error for different stuff here, right? Ooh, isn't it? This is amazing, friend. Because now we have the messages. We can have which item we had the problem, so we can metrify, and actually we can measure it as a string, not parsing, because sometimes when you get the whole chunk that is not a correct chunk, or is not a correct JSON, it's gonna break. So this way you can handle errors properly using child processes. So this is perfect for you for splitting programs. So yeah. We've used the fork function for the child process, but you'd see a lot of examples on the internet using the spawn function, which is used to run binaries or SEO commands from Node.js. This means that you can parallelize functions sending and receiving information as streams from other programming languages, such as Python, Golang, Rust, Ruby, a lot of others from a Node.js projects. Child processes are heavy for the operating system as they establish a communication channel, have their own allocated resources such as memory and CPU, and they don't share resources with other processes. They are just a small box with everything there. Still, they are the best way for parallelizing asynchronous operations such as reading files, aggregating data from web APIs, database processing, and much more. However, for CPU-intensive operations, we use worker threads, and in the next class, you're gonna dive into this subject and figure out the difference between child processes and worker threads. I hope this class has exceeded your expectations, my friend. Let me know here in the comments below what you find about this class. I really want to know what ideas this gives to you. I'm Eric Wendell, and I will see you in the next video.